Hello, grade 11 students. It's always nice seeing you back. Welcome to another lesson about Earth and Life Science. Let us start our journey in learning more about relativeness of relative and absolute dating to determine the subdivisions of geologic time. Ladies and gentlemen, our lesson 13, Relative and Absolute Dating. You will have to explain how relative and absolute dating were used to determine the subdivisions of geologic time. Specifically, this module will help you to differentiate relative from absolute dating through pictures presented, and compare relative and absolute dating using comparison chart. Interpreting the Earth history is a primary goal of a scientist in the field of geology. Like a modern-day investigator, a geologist must interpret the clues. By studying the rocks, the geologist found in the preserved rocks some evidences in its features which is contained from the inside. Geologists can unravel the complexities of the past. Dating techniques are used by scientists in the field of geology to determine the age of rocks. When geologists date rocks, they are determining how long ago they formed. The geologists establish the age of rocks in two ways: relative and absolute dating. Relative dating is when you give the age of a rock or fossil compared to another rock or fossil. It is determining how old something is compared to something else. It uses words like older or younger instead of exact numbers. The principle of cross-cutting relationships states that a fault or intrusion is younger than the rocks that it cuts through. The fault cuts through all three sedimentary rock layers, or A, B, and C in this figure, and also the intrusion, or D. So, the fault must be the youngest feature. The intrusion, D, cuts through the three sedimentary rock layers, so it must be younger than those layers. By the law of superposition, C is the oldest sedimentary rock, B is younger, and A is still younger. The full sequence of events is layer C formed, that's the first event. Second, layer B formed. 3, or the third event, layer A formed. Fourth, after layers A, B, and C were present, intrusion D cut across all three. 5. Fault E formed, shifting rocks A through C and intrusion D. And sixth, weathering and erosion created a layer of soil on top of layer A. Remember that in this type of dating, the actual age in years is not determined. Let's recall the stratigraphic laws applicable in relative dating. Law of superposition. When sedimentary rock layers are deposited, younger layers are on top of older deposits. Law of original horizontality. Sedimentary rock layers are deposited horizontally. If they are tilted, folded, or broken, it happened later. Law of cross-cutting relationships. If an igneous intrusion or a fault cuts through existing rocks, the intrusion or fault is younger than the rock it cuts through. Look at this illustration and try to figure out the comparison between relative dating and absolute dating. Correct. That's a good observation. It's time to study absolute dating and reveal the difference between these two types of dating techniques. Absolute dating is a method of measuring the absolute age of an event or object. In determining the absolute age of rocks and fossils, scientists analyze isotopes of radioactive elements. The absolute dating is determining how old something is. It uses numbers in millions of years or MYA, and it only works for igneous rocks. Isotopes are atoms of the same element which have the similar number of protons, but they have different numbers of neutrons. Most of the isotopes are stable that they are in their original form. The other isotopes are unstable. They need to break down into stable isotopes or other elements, and so they are called radioactive. The radioactive decay is the process by which an unstable atomic nucleus loses energy by radiation. It is occurring on a steady state. We can use the relative amounts of unstable and stable isotopes present to determine the age of an object. It breaks down unstable radioactive isotopes into stable isotopes. The parent isotope is the unstable radioactive isotopes, while daughter isotope is the stable isotope produced by radioactive decay of the parent isotope. The rate of radioactive decay is constant. That is why comparing the amount of parent material with the amount of the daughter material is important in dating rocks. In other words, the more daughter material there is, the older the rock. Again, the parent isotope is the unstable radioactive isotope, and the daughter isotope is the stable isotope produced by the radioactive decay of the parent isotope. Consider the following figure. From one parent isotope, it undergoes radioactive decay and produces daughter isotope and heat. Here are common isotopes used in radiometric dating. Carbon-14 is the parent isotope, while its daughter isotope is the nitrogen-14. Potassium-40 produces a daughter material of argon-40. Rubidium-87 produces strontium-87. Uranium-238 and uranium-235 produce lead-206 and 207 respectively. This figure or this table also shows the half-life of parent isotopes. Example, carbon-14 has 5,730 years half-life, and its useful range is from 100 years to 30,000 years. The half-life, by the way, is the time needed for half of a sample of a radioactive element to undergo radioactive decay and form daughter isotopes. After one half-life has passed, one half of the parent isotope has changed into daughter isotopes. This picture gives a simplified explanation of how radiometric dating works. The parent isotopes are red circles and daughter isotopes are blue. We start off at time 0 with 20 atoms of the parent isotope. In this system, the radioactive parent isotope has a 50% chance of radioactively decaying within 10 minutes. That means that after 10 minutes, 50% of the parent atoms have decayed and changed into the daughter isotope. That means that at t equals 10 minutes, our sample now contains 10 atoms of parent and 10 atoms of daughter. 10 minutes later, or 20 minutes, 50% of the atoms of parent isotope have decayed, adding an extra 5 daughter isotopes. At t is to 20 minutes, there are 5 parent isotopes and 15 daughter isotopes. Notice that the number of radioactive decays, or parent changing to daughter, is not a set number for a given time or period. There were 10 decays in the first 10 minutes and only 5 decays in the next 10 minutes. The rate of radioactive decay is proportional to the amount of parent isotope. So, the more parent isotopes you have, the greater the rate of change from parent to daughter. This means that radioactive decay is an exponential process. That ends our lesson today. Congratulations. Keep safe by staying at home. See ya.